Hey everybody, we're going to talk about using R and fitting our two variables today. And we're going to look at a particular story, and it's attached to this same output that your movie's in. And we're going to take a look at a file called ex07-54noise.rda, and we'll talk about where I stole it from later. Now, in the Mac, if you double click on this, it should open up R right away. But of course I already had R open. Alright, oh there it is, okay. And if I look to see if I type in objects, the only thing that should be in there is an object called ex07_54noise, which is what I want. All I want is that stuff. So you can see I've been playing with this a little bit already. And let's see about what's going on with this. So I'm going to type in my str. Okay, oops. So obviously I can't type tonight. 54 noise. Okay, so you have decibels and you have intensity. And if you read through your problem, what they did is take samples at two different gyms to test to see hearing level, or how loud the noise was at two different gyms. So what we're going to do is our usual procedure with testing with the variance.test to determine if we should be using the pooled variance. And then we're going to test the claim that the first gym, which is really the factor 1, is greater than factor 2, or the low one. Okay? Now, well, you'll see in a minute what's going to happen. I'm going to type in, I wanted you to see two things in this, how you use use an R workspace. If you noticed, when we brought in the file, and when you double click on it, it does it automatically. It uses a function called load, and the extension on there was .rda. So you don't really have to type or anything. That's pretty good. Alright, and I'm going to check on this with Windows too. I'm using this on the Mac, but I'm pretty sure the same thing is going to happen in Windows. Alrighty, so I'm going to type in var.test. And that's going to be decibels, tilde, intensity, comma, data equals ex07. And remember, this is for your F test, so you're going to leave everything alone. You're not going to do anything to it. So we're going to look to see, okay, if we were looking for our F star, that would be the 0.38. The p-value is 0.03 though. Okay, now if we were going to write this out like you should, I'm going to do it on the screen, but you're going to be writing this out with pencils. You're going to have HO is sigma 1 squared, sigma 1 squared is equal to sigma 2 squared versus, I'm just going to write in not equal, and do it right. Don't be like me. You don't want to end up like me. And then the p-value in this case is the 0.03038, and that's from here, right? Not the F star value, but the p-value. Okay? Then our if then, of course, is if p is less than alpha, and our alpha was 0.05, then we reject HO. Then we reject HO, and of course we reject HO. And this was part of the reason that I wanted to do this problem in the movie, because we haven't done anything like this. So this will tell us, okay, we want to use the non-pooled variance in the second part. And I'll show you how to do that in a second. Okay, so are you comfortable with this? Good. I'll take that as a big yes. All right. So then the second part, we want to use that the first one is greater than the second. So we're going to have our t dot test. You're still going to use the same setup. Decibels, oops, tilde, intensity, data equals EX, whatever. Okay, now the alternate is going to be greater than, so I'm just going to put greater. Then the default for the variances not being equal, or excuse me, the variance dot equal, it actually defaults to false. So we don't have to put that in. So we're going to hit enter. And it's going to do the Welch's, what's called the Welch's 2-sample test. And you know how we did all that ugly stuff when we did the degrees of freedom? It calculates that for us. It doesn't do the nearest integer like we did by hand the other day, but it does go through all the bells and whistles, and it will go ahead and generate the p-value. Okay? So if we were going to do the test of hypotheses with our pencils, we would do HO mu less than or equal to, mu1 less than or equal to mu2 versus mu1 greater than mu2. Okay? And then our test statistic is the p-value, and that is the 1.76, 76 e to the minus 05. So that's really decimal point 40176. And if p is less than alpha, in this case our alpha is 0.05, then we reject HO. HO. And of course, we reject HO. Okay, hope this helps.